Hello everyone, we are Group 98 Sydney and we are doing project on diagnosing Parkinson's disease using voice sample data analysis. So what is Parkinson's disease? It's a movement disorder of the nervous system that gets worse over time. There is no specific test for PD. Diagnosis is based on medical history, neurological exams and ruling out other conditions. Growing interest in developing new non-invasive methods for diagnosing PD. One possible non-invasive method for diagnosis is analyzing person's speech data. Here's a project roadmap: dataset overview and data wrangling, data preprocessing, inferential statistics, visualization and findings. Dataset overview. Data measurement is extracted from 20 people suffering with PD and 20 healthy persons, a total amount of 40 people. Each subject records 26 different voice samples. 26 acoustic features extracted using acoustic analysis software called PRAT. Each contains different categories like jitter, shimmer, harmonicity, pitch, pulse, voice, etc. A total of 40 people gave 26 samples. Therefore, there are 1040 rows.
So the next step is data pre-processing. So the given data set is in .txt, so we have converted it into .csv format. So in this data pre-processing, we are looking for the missing value. So for this we are using the function isNull. So this involves filling missing values, smoothing noise data, detecting and removing outliers, and resolving inconsistencies. So in the data set about Parkinson's disease and voice sample, suppose some subjects didn't provide all the 26 voice samples. These missing samples could be filled using a method like mean imputation, where we substitute the missing value with the average of the available values. So the data, from this we find out that there are no any missing value. The data set was split into two sets to conduct the t-test, one group with PD and the other group with without PD. So from here we can see that there are 1039 rows and we have 29 columns with all the 26 samples and features and UPDRS and PD indicators. So the next step is t-test. So purpose of the t-test is to determine if there is a statistically significant difference in the mean of selected features between the PD and non-PD group. So the main objective of our project is to identify silent voice feature that could distinguish between people with PD and those without. So by applying the t-test to each voice feature, we can determine which features show a statistically significant difference in mean between the PD and non-PD group. This assists in selecting relevant features for potential diagnostic purposes. The result of the t-test can guide further analysis. Features that show significantly different might be prioritized in subsequent predictive models or machine learning tasks. Conversely, features that do not show significant difference might be considered for removal to simplify the model, although other factors would also play a very important role in such decision. So our project aims to determine the extent to which the severity of Parkinson's disease can be non-invasive diagnosed using voice sample data. The t-test directly support the aim by providing evidence on which voice features show a significant difference between PD and non-PD individuals. These features that exhibit significant difference between the become prime candidates for further investigation as potential diagnostic markers. So here we can see that from the figure. So from the result of t-test, we see that UPDRS have the extremely low p-value. So this finding is expected as the UPDRS score is a clinical measure used to determine the severity of Parkinson's disease. It is extremely low p-value indicate a significant difference between the PD and non-PD group, validating its role as a reliable indicator of disease severity. So secondly, jitter absolute. So the jitter absolute voice feature shows a statistically significant difference between the two groups. This means that this particular measure of voice irregularity might be influenced by the presence of PD. Thus, it is a strong candidate for differentiating between PD and non-PD subjects based on voice samples. And then comes the Shimmer APQ11. So the another voice feature, Shimmer APQ11, also exhibits a notable difference between the PD and non-PD groups, like jitter absolute. This suggests that this measure of voice amplitude variation could be relevant in detecting Parkinson disease presence. So as a overall, these t-test findings provide robust evidence on which voice features are more promising in differentiating between the individuals with and without Parkinson disease. Features with very low p-value, close to zero, are particularly compelling and should be prioritized in any subsequent analysis or modeling features. By identifying these significant features, the project is better positioned to develop a non-invasive diagnostic tools for Parkinson disease using voice sample data. The t-test have effectively narrowed down the list of voice features that are more associated with the presence of the disease.
While the p-value tells us if an effect exists, the correlation coefficient tells us how strong or important this effect is. A feature can have a low p-value but still have a low correlation coefficient, meaning the relationship, while it is significant but is weak. However, the magnitude of their correlation coefficient will determine which features are more impactful or relevant. For example, a feature with a correlation coefficient of 0.75 would generally be considered to have a stronger relationship with the PD indicator than a feature with a correlation coefficient of 0.25, even if both the p-values are less than 0.05. In this way, correlation matrix helps in feature selection. Given that we want to determine a set of salient features that could distinguish people with PD from those that are healthy, the correlation matrix can quickly show which features have a strong relationship with the PD indicator. PD indicator and UPDRS readings, as we have obtained, have a strong positive correlation of 0.755. This is expected as UPDRS is a clinical measure. Features such as jitter absolute, shimmer, APQ11, and jitter RAP have positive correlation with the PD indicator, suggests that their potential role in PD diagnosis. The given chart shows the top 10 features correlated with the PD indicator. As it is expected, UPDRS has the highest correlation coefficient with the PD indicator since it's a clinical measure. After that, we have jitter absolute, shimmer APQ11, and jitter RAP. Moreover, we have plotted a box plot of jitter absolute grouped by PD indicator to gain valuable insights on our data. A noticeable difference in the medians of both groups indicates a significant difference in the central tendency of the two groups. Since there's a clear difference between the two groups, it strengthens the argument that jitter absolute is a salient feature for distinguishing individuals who have Parkinson's disease and those without Parkinson's disease. It indicates that jitter absolute is an important feature for PDD diagnosis. So, in a nutshell, our investigation into the data reveals several acoustic features that have a significant difference between the PPD and the no PPD groups, specifically UPDRS, jitter absolute, shimmer APQ11. The p-value findings coincide with the correlation matrix and the box plots as well. The analysis clearly showcases the potential of using voice data as a non-invasive method for Parkinson's disease. Thank you.